Humanity has always dreamed of exploring the stars, crossing the cosmos in search of new worlds. But are we destined to remain trapped within the solar system forever? Skeptics argue that the laws of physics, like the impossibility of reaching the speed of light, make interstellar travel nothing more than a fantasy. However, science shows us that we don't need to break these laws to reach other star systems. With creativity and technology, leaving the solar system is not only possible, it's inevitable. Let's explore why. Curiosity is the force that drives us. Ever since Galileo pointed his telescope at Jupiter and revealed its moons to the Voyager probes, now traveling through interstellar space over 22 billion kilometers away from Earth, we've proven our ability to go beyond. Launched in 1977, the Voyager spacecraft crossed the heliopause, the boundary where the solar wind meets interstellar space, proving that we've already begun to leave the solar system. Even if it's only with machines, our destiny is greater. The discovery of more than 5,000 exoplanets, many within the habitable zone, like Proxima b, located just 4.24 light-years away in the Proxima Centauri system, gives us a clear goal: to find habitable worlds. Beyond that, threats like asteroid impacts or the future expansion of the Sun, which in a few billion years will make Earth uninhabitable, force us to search for new homes. Interstellar exploration is not just about curiosity. It's a matter of survival. Skeptics argue that the speed of light, around 300,000 kilometers per second, is an absolute limit. After all, accelerating a massive object to that speed would require infinite energy, according to Einstein's theory of relativity. And that's true. But we don't need to reach light speed to explore other systems. The Breakthrough Starshot project proposes nanospacecraft equipped with solar sails, pushed by ground-based lasers. These could reach 15 to 20% of the speed of light, about 60,000 kilometers per second, allowing them to arrive at Proxima Centauri in just 20 to 30 years. The technology behind solar sails has already been tested. In 2010, Japan launched the Icaros mission, which used sunlight pressure to navigate. Breakthrough Starshot plans to send thousands of tiny probes, weighing just a few grams, eliminating the need to carry fuel on board, a clever workaround to the mass-related challenges often raised by skeptics. Another promising solution is nuclear fusion propulsion. Critics point out that the energy required to reach high speeds is impractical. But again, we don't need to hit 100% of light speed. Nuclear pulse engines, inspired by Project Orion from the 1950s, could potentially reach 5 to 10% of light speed. That would be enough for interstellar travel in decades, not millennia. Fusion reactor advancements, like magnetic confinement systems, are making progress. In 2024, experiments in China and the United States managed to sustain fusion reactions for several minutes, bringing us closer to compact reactors that could power space vessels. These technologies use energy efficiently, without breaking the laws of physics, making interstellar travel feasible within human timeframes. Skeptics also warn that space isn't empty. Interstellar particles, like hydrogen atoms, could become deadly projectiles at high speeds, damaging spacecraft and exposing crews to radiation. That's a real challenge. But science offers solutions. Magnetic shields, inspired by Earth's magnetic field, can deflect charged particles. Experiments in labs like those at MIT confirm the feasibility of artificial magnetic fields for protection. For larger dust particles which could cause serious damage, laser detection systems, similar to those used in modern telescopes, can map obstacles and adjust the spacecraft's trajectory. These technologies show that space's hostile environment can be managed even without extreme speeds. Skeptics claim that interstellar travel is unfeasible because at near light speeds, time passes much more slowly for the crew. This creates drastic differences relative to Earth. For example, a trip at 99.99% of the speed of light to the Andromeda Galaxy, located about 2,500,000 light-years away, would feel like only 11 years for the crew, but millions of years would pass on Earth. For closer systems like Proxima Centauri, at 4.24 light-years away, the impact is much smaller. At 20% of light speed, the trip would take around 21 years for the travelers, with only a slight difference in time experienced back on Earth. In addition, generation ships offer a practical solution. These vessels, designed to support communities for decades or even centuries, would use life support systems, like those tested aboard the International Space Station, to sustain entire populations. Time dilation does not prevent exploration. It simply demands strategic planning. Another common argument from skeptics is that gravitational forces caused by prolonged acceleration would be unsustainable for the human body, which cannot endure more than 1 g for extended periods. And that's true, but we don't need extreme acceleration. To reach 10% of the speed of light, a spacecraft could accelerate at 1 g for about 35 days, a tolerable duration with the help of advanced pressure suits and shock-absorbing systems. Furthermore, human hibernation, metastasis, is being researched to reduce astronauts' metabolic needs. Studies on rodents, such as those conducted by Harvard University, have shown that inducing hibernation is possible, and preliminary human trials are already underway. This technology would allow for long-duration space travel without exposing the crew to continuous gravitational forces for months, bypassing the physical limitations highlighted by skeptics. Artificial intelligence will be a cornerstone of these journeys. Skeptics often ignore the role of AI, but it can manage autonomous spacecraft, perform in-flight repairs, and make critical real-time decisions. AI models are already analyzing data from telescopes like the James Webb, and in the future, they could guide interstellar routes, avoiding cosmic obstacles. Three-dimensional printing in space, already tested aboard the International Space Station for manufacturing tools, will make it possible to construct habitats on exoplanets using local materials, reducing the need to transport massive cargo. Before human missions, robotic probes, such as those planned by the Breakthrough Starshot project, will map star systems to ensure that our destinations are viable. These technologies overcome practical barriers, like the need for massive amounts of fuel and energy, often cited by skeptics. Skeptics also question the economic feasibility, suggesting the required resources are prohibitively expensive. But space mining is emerging as a promising solution. Asteroids within the belt between Mars and Jupiter contain rare metals like platinum and gases such as helium-3, ideal for fusion reactors. Companies like Astroford are planning mining missions for the year 2026, and NASA is already studying resource extraction from moons around Jupiter. Space-based solar panels, placed in orbit, could capture solar energy without atmospheric losses, providing abundant power for interstellar missions. These resources help build a sustainable space economy, countering the argument that energy costs are an insurmountable obstacle. Skeptics frequently dismiss ideas like warp drives or wormholes, arguing that they rely on exotic matter, something never observed, and would likely be unstable. And that is true. But interstellar exploration does not require breaking the laws of physics. The Alcubierre metric, which inspired the concept of a warp drive, is speculative, but it fuels research into space-time manipulation. Even without exotic matter, technologies like solar sails and nuclear fusion propulsion are sufficient to reach nearby systems, such as Alpha Centauri. Wormholes, though unstable in theory, inspire research that may lead to unexpected discoveries. Science progresses by exploring what once seemed impossible, just as we did when overcoming barriers that were once thought insurmountable. Once, crossing oceans or reaching the moon seemed unthinkable. Today, exploring other star systems may feel the same. But history proves that humanity has always overcome its own limits. Global collaboration is another crucial factor often overlooked by skeptics. The International Space Station shows that nations can unite for cosmic goals. Agencies such as NASA, the European Space Agency, and the China National Space Administration, along with private companies like SpaceX and Blue Origin, are investing billions of dollars in space technologies. SpaceX, with its Starship project, has significantly reduced launch costs. Its reusable technology could be adapted for future interstellar spacecraft. The Artemis program, which plans to build permanent lunar bases, is a major step towards sustainable space infrastructure, capable of supporting even more ambitious missions. Partnerships between public and private sectors are accelerating the development of space habitats and advanced life support systems. These are essential for long-duration travel and prove that interstellar exploration is a viable collective effort. Skeptics also argue that, even at high speeds, destinations may change, that planets once considered habitable could become hostile before a crew even arrives. However, robotic exploration solves this problem. Advanced probes, like those proposed by the Breakthrough Starshot initiative. These probes will be launched years in advance, collecting real-time data on exoplanets, supported by telescopes like the James Webb, to confirm the conditions before any human mission is attempted. Systems like Alpha Centauri offer multiple potential targets, significantly increasing the chances of success. Humanity does not need a perfect destination, only viable options, and science is giving us those options. In the end, perhaps the most powerful and often underestimated an argument against the skeptics is the survival of our species. Threats like climate change, asteroid impacts, or the inevitable death of the Sun in about 5 billion years force us to think beyond Earth. Becoming a multiplanetary civilization, starting with Mars and eventually reaching distant star systems, is a long-term survival strategy. Carl Sagan once said that space exploration is our insurance policy for survival. Every step, from the Voyager probes, now crossing interstellar space, to projects like Breakthrough Starshot, brings us closer to that future. We don't need to reach the speed of light. We just need to use physics wisely. In just a few decades, probes will reach Proxima Centauri, and in a century perhaps even crewed spacecraft. The universe is vast, but our determination is greater. Leaving the solar system is the next chapter of humanity, and it's closer than ever. The destiny of humankind has never been bound to Earth. It has always been anchored in our will to go beyond. If the universe is the stage, then we are the explorers. If you believe the future of our species lies among the stars, then join us on this journey. Like this video, subscribe to the channel, and activate the notification bell so you don't miss the next chapters of this cosmic odyssey, because the future has already begun, and it lies beyond the solar system. I'm Commander Marcos, and this is Crônicas Estelares, where every shadow of space hides a story. Thank you for watching, and until the next stellar curiosity.